Hey guys, today we're going to be learning about the never boring Niels Bohr. He's one of the most commonly discussed physicists that high school students often dedicate units in chemistry class to. Bohr was a Danish physicist, philosopher, and a huge advocate for scientific research. Niels was born on October 7, 1885 in Denmark as a son of Dr. Christian Bohr, a professor of physiology at Copenhagen University. Niels Bohr's childhood was spent around academic geniuses, with both parents being distinguished teachers in their fields, so studying came to Niels naturally. In 1909, Bohr took his master's degree in physics and his doctorate degree in 1911 as the Copenhagen University legacy. He then traveled to England in 1911 to work with J. Thomson, the founder of the famous plum pudding model. Although Bohr's attempt to impress J. Thomson with his experiments ended in vain, he later received an earnest invitation from Ernest Rutherford. Through his interactions with Rutherford, Bohr was exposed to Rutherford's nuclear model, based on which he tried to explain the properties of metals. Bohr's theoretical explanation of properties of metals with the aid of the electron theory remains a subject classic. But it was through this project that Bohr first stumbled upon the implications of Planck's quantum theory of radiation. Starting in the spring of 1912, Bohr intensely dove into studies concerning radioactive phenomena and the research on the study of atoms, which was successful in terms of Bohr being able to present a picture of atomic structure. This is also the year Niels married his wife, whom he eventually had 6 sons with. In 1916, the Institute of Theoretical Physics was established for Niels Bohr at Copenhagen University, and it is there that Bohr became professor of theoretical physics. Niels Bohr then won 9 highly esteemed awards, the most famous of which included the Nobel Prize in Physics, 1922, the Copley Medal, 1938, and the Atoms for Peace Award, 1957. As a friend of Einstein, Niels Bohr is also known for exclamating, "Einstein, stop telling God what to do." We will now talk about the rest of Niels Bohr's amazing accomplishments, both in and out of his lab coat. As a close colleague of Rutherford, Bohr started to develop arguably his most revolutionary work, the Planetary Model. In 1912, Rutherford and some of his collaborators established a theory which states the atom consists of a heavy and positively charged nucleus with lightly negatively charged electrons circling around them. However, Bohr felt compelled to publish his own theory regarding the compositions of an atom in a physiological magazine in 1913. Ford's nuclear model postulates that electrons just randomly orbit around the nucleus of an atom, whereas Bohr's planetary model assumed that electrons orbit in a fixed trajectory and their location can be estimated, just like how planets such as Earth, Mars, Jupiter, and Mercury orbit around the Sun in fixed courses. Bohr states that electrons can also do so around the nucleus of an atom. He named such fixed course of atoms energy levels. His early research on Planck's electromagnetic radiations also played a role in Bohr's planetary model. According to the planetary model, energy is being emitted, sometimes in the form of light, when electrons jump or fall from one energy to another. Although it was unacceptable to most physicists at that time, the Bohr atomic model was able to account for an ever-increasing number of data. Bohr was awarded the Nobel Prize for his work on developing an elaborate scheme of the periodic table by adding electrons one after the other to the atom according to his atomic model in 1922. The planetary model also shed light on a long-established argument regarding the properties of light in the field of physics by developing the complementarity principle. Before the principle, physicists have been arguing the properties of light and have formed two major claims. Some believe light is composed of traveling particles called photons, while the others believe that light contains of pure energy waves. Bohr's complementarity model offered a new perspective to both parties by proposing the idea of wave-like duality, which means light and electrons are sometimes wave-like and sometimes particle-like. This novel insight became the pedestal of later scientific studies. Next video, look forward to learning about Edwin Schrödinger and his cat who's literally going through an existential crisis.